30 minutes in, so thank you.
Okay, hello and welcome to my session. Okay, my name is Siliwat Sutipanyo and Miss Silia Sankamo. Okay, we are from wireless map, the modern geospatial platform. Okay, we install it and in this one. Okay. I will overview my project. Okay, we have a dealing with a massive data set like a building footprint in Thailand, and if you see it is a Buddha in Sukhothai. Okay. The building data we are dealing with around 41 million, and we are stored in product storage. Okay, the source is around from the GSTA government and the Google and Microsoft building footprint. Okay, that we store on the platform. So we need to convert the building into the 3D model. Okay. Its goal is visual building footprint as a 3D tile and render on the map with speed and provide data management that we can edit the building footprint or create new building footprint. Then the data will change in the maybe near real time because it have time to processing for new data, and we ensure for high performance when we try to play on map and score to see the building. It have a speed to. Okay, sorry. And this is a challenge in our project. We found problem of the processing scalability. That's because we try to process all of the data in one single batch. So we know that is impossible, and the performance that we are processing is never built finished yet. And the third, the data maintenance. If we need to edit the data one building and we need to regenerate all of the 41 million, that is crazy. Okay, and cost we use is so much, and we need to take a supercomputer to processing it. Okay, so that is the technique we implement for the project.
Okay, so in order to deal with the challenges and our goals, these are the techniques that we use. And first, we use the data partitioning using the Google S2 grid. And next, we try to generate the building into 3D. So we use the 3D tile generation using the Marco 3D tiler. And next, we manage it with the virtual tileset, which you will know later. And the last one, we try to merge the multiple tilesets using the Cesium 3D tiles tool. Okay, so why we use S2? We use S2 because it's a standard in practice that everyone use, and it also the global grid system that provides the consistent grid for the entire globe. And the data partitioning, it it helps us partition our 41 million data into the chunk that manageable, and it also graphically based chunks. Okay, so why we choose the S2 level 9? Because the S2 level 9, it has the approximate cell granularity, and the size that it used to chunk our data, it is manageable for our 41 million building data. Okay, so the 1,535 is the number of S2 grid level 9 that cover the Thailand area. And for the grid that has the maximum number of features is around 950,000, which is the area in the Bangkok and Nonthaburi, which is near the capital city. That's why we have the many buildings. Yeah, so we apply the data partition, and our data, you can see in the red box that we add the attribute or the property S2 ID to see this building belong to what S2 grid. And this help us able to manage the building footprint data later if user want to edit some building in the small S2 grid. User just input the building for that grid, and our system just process and update the data in that grid only. It doesn't affect the 41 million building. Yeah, so right now we have the building data that split into chunks using S2 grid. Next, we want to generate it into the 3D tile. So we use the Marco 3D tiler. This is implemented by our friend Gaia 3D. It's an open source based OGC 3D tiles generator, and it supports multi-format for 3D data such as the 3ds, OBJ, and many more. And we also use its key feature, which is the 2D to 3D extrusion. We input the building data in 2D GeoJSON and extrude it in the 3D model. And we also input the geotiff dem to set the building to be the real height of the ground, like that. And for the geotiff dem, we also use the NASA 90-meter dem. Okay, so right now the 1,535 chunks have generated into the 3D model. So right now we have the 1,535 tileset JSON that are ready to render on the web. For the tileset JSON and for the 3D data, you can just put on the file server or the object storage, and for the serve it on the web, on the map. Yeah. But if we want to render the building data for the whole country, just in Thailand, we need to initial the 1,500 more tilesets. And in this picture, we just demonstrate only initialize around 14 tilesets. But let's imagine if we initialize all 1,535 tilesets, it can lead to many problems, such as it loads not unnecessary data, because if we zoom into some area like Bangkok, maybe it loads the data in some other area which is unnecessary, and it may waste the load on the client side and decrease the performance too. So after we researching the 3D tile specification, we come up with the adaptation, which is the virtual tileset, which is the keyword for this presentation. The virtual tileset concept is actually based on the 3D tiles root and children hierarchical relationship and the external tileset concept. Our virtual tileset, it will act as a single root, which is the starting point, and that root will contain the link that will link you to the child to S2 grid cells. And it also localized update, which is when you edit some specific S2 grid cell, you just have to regenerate 3D tiles for that grid only, and you just recalculate the root tileset, and it just affect the small grid like that. Okay, so the virtual tileset is act as a single root, right? So we need to use another tool, which is the cesium 3D tiles tool. The cesium 3D tiles tool is a command line toolkit and tools and utility for converting, optimizing, processing, and analyze the 3D tiles data. And we use the command the merge JSON to merge the multiple tileset into a single tileset JSON file, which will be our virtual tileset. Okay, so this is okay, so this is after we generate it into the virtual tileset. On the first box, the first line, you will see that it only initial the 3D tileset, which is the virtual tileset, and for the box that on below, it only rendering visible only rendering, which means when you zoom into some area, it only load the tileset and the 3D data of that area only. To explain more, the tiles, when the tile is first created, the content is not loaded, but when the content is loaded on demand when so this is the result. On the left, you can see the list of 3D tiles collection, 3D collections based on the S2 grid in around Thailand area. And when you zoom in some area, it will load only that S2 grid 3D tiles and 3D data. Okay, for the processing result, our service is running on the Kubernetes cluster with the shared resource. For the 3D tiles generation, we pick up the S2 grid that has the most features, which is around 950K. It took around 15 minutes to process that S2 grid cell into the 3D tiles. The worker resource usage is around CPU 3 core and memory for 20 gigabytes. For the virtual tileset merging, for 1,535 children, it took around 19 seconds, which our background process in the background is validate and merge JSON and save that file into the S3. The service usage is around CPU around 0.4 core and memory around 70 megabytes.
Okay, so and for key feature, that's we know the data will not processing all one time, but we can separate to chunk or partition and generate, and we can join them and all merge to one tileset and use its performance is equally and stable. Okay. So and the partitioning can enable to the module. Okay. And the virtual tileset is a glue that can join every student of tileset in single one and render it lightly in one. Okay.
Okay, for the next step of our project is the 3D. It's a complex 3D transformation. We want to investigate the method to efficiently manage the transformation like translation, rotation, and scaling on the individual tileset and correctly reflect those changes within the main virtual tileset, which will be more complicated because when you translate or transform the child tileset, it will have to affect the virtual tileset too. That we want to make that process efficient. Yeah, so thank you everyone for joining this session, and this is a presentation slide if you would like to scan. Yeah, thank you.
Thank you.
Do we have any questions for the speakers? All right, well, I'll ask a question. You talk about this processing pipeline and the times involved. How frequently is this data changing, that it updates? Does that impact how often you need to run this processing pipeline? Or is it fairly static data?
Maybe the data will we receive from the client and we just upload maybe.
We are not sure how frequently the data will change because the user that use the system, if there are more new building, maybe they will input the new building and we need to generate it. But I think it's not that frequent. Maybe it's the round of their data rechecking. Yeah, something like that.
Any more questions? Okay, well, thank you, Sarawat and Siriani, for the presentation.